Alright guys, welcome. I'm going to make this video very quick, or as quick as I can, to talk about seafloor spreading and some of the things that we need to know from it. But if you haven't checked the key for this document, please go back and do that. It's very important. Alright, now the longest mountain range in the world, I guarantee if you guys plug this one into Google, what it kicked out at you was the Andes. And while the Andes are the longest land mountain range in the world, they're not actually the longest mountain range in the world. We actually have this mountain range. See, the Andes are here. They are along the western coast of South America. And while they are the longest land mountain range in the world, we have this ridge, this mountain range right here called the Mid-Atlantic Ridge, and that is an underwater mountain range. And you can see it stretches all the way from Iceland all the way down the globe towards the southern part of South America. And, you know, we wouldn't have even found that if it wouldn't have been for this technology that you read about called sonar, in which we send out sound waves and that bounces back the depths of the ocean back up to the boat so that we can actually map what the ocean floor looks like. And that is how we kind of found these things called these mid-ocean ridges, these mountains that exist in the middle of the ocean. Now, the way that those things form is through this process called seafloor spreading. And we've already talked a lot about convection currents. Well, the convection currents drive seafloor spreading. What they do is they force magma, they force this molten material up towards the crust. And we kind of already mentioned that the crust, because it has all this stuff, this molten material thrown up at it, that it's going to actually push the crust off to the side. So a little bit comes out, we get this new rock that kind of comes out here, but we also get these pieces of crust just kind of pushed away. All right, it's a conveyor belt, really, is what it is just this molten material coming up and pushing the crust away. And we can see it here in this GIF, the molten material coming up and sliding that seafloor away. It's literally pushing the seafloor apart. That's why we call it seafloor spreading. And we get these ridges as the result of where the seafloor is actually spreading. So the seafloor is going away from the ridges. Now, without sonar, we wouldn't have known that those ridges are there. And then it's also interesting that we found some pieces of evidence to support that this happened. So I'll do a video that goes a little bit more in detail about these pieces of evidence. But the pieces of evidence are pillow rock, and this is the only type of rock that can form when it comes out of the earth and then immediately cools by the ocean. We also have older rocks being further away from the ridge, and the newer rocks are closer to. So I'm actually going to show you on this picture because I think this one does it maybe a little bit better. But the older rocks are over here, and the newer rocks are over here, meaning that when they come up, they harden, they're brand new, but then the seafloor gets pushed away. So those rocks become older, whereas the more rocks continue to push up and replace those newer rocks, all right? And the last piece of evidence is these magnetized stripes. Now this one's really complicated. It has to do with the polarity of Earth. So when, you know, the polarity was normal, when it was going north, we have the rocks being pulled in one direction, okay, because the rocks are made out of some sort of metal material, so they want to go in one direction. And then when polarity gets reversed, they traveled in another. So you can see here that based on these stripes, we can see that Earth's polarity changed, but also that the seafloor was spreading as the time went on and the stripes changed along the seafloor. Now, as we also have these things called trenches. So we have mid-ocean ridges, we have seafloor spreading, but we also have trenches. So we have our ridge here, and it's pushing this plate this way towards the land. Now, where the ocean plate runs into the land plate, we get this really, really deep area of the ocean called a trench. And that forms by this process that we call subduction. Subduction is when one plate runs into the other one and it goes underneath of it. That is called subduction. When that happens, a trench forms in its place, and these trenches can be massive. Mount Everest can fit inside of some of the deepest trenches on Earth. All right. Now, just kind of in summary, we've got four things that we got to worry about. We need to know mid-ocean ridges. They are in the middle of the ocean. They are caused by seafloor spreading. You guys can see the two plates in the middle of the seafloor spreading apart. And then we have, when plates run into each other, we get one plate that kind of goes underneath of it, called a subduction, the process of subduction. And when we have subduction, we form this deep area of the ocean called a trench. Now again, you're going to check this diagram out kind of on that key, but I did want to go over this real quick, and it says explain why the Pacific Ocean will eventually disappear. And if we look at this, we know that our mid-Atlantic ridge is right here, and we can see the direction that those plates are moving. So we're being pushed, the North America is being pushed this way to the west, and Europe is being pushed this way to the east, South America is going to the west, Africa is going to the east, they're pushing away from each other. Well, what does that mean for the Pacific Ocean? If North America is coming this way and Asia and Europe are coming this way, will the Pacific Ocean eventually disappear? And the answer is yes, because those are areas of convergence. Those are areas where the two continents are coming closer together. Guys, if you're confused on this, please watch this again. I am going to come out with some other videos about trenches and subduction, about ridges and seafloor spreading, and those pieces of evidence. But please consult your teachers if you're a little confused, if you need a little bit of help. We are here for you. Just let us know.